Hello everyone. Today we'll be working on LeetCode 501, find mode in binary search tree. We're given a root of a binary search tree and they want us to return the number or numbers with the most appearances in the tree. We can tackle this problem in a couple of ways. We could create a hash map, make the numbers we've come across keys of the map, and increment the value every time we come across the same value again. We could then loop over our map and do some comparisons to see what the largest is and store the largest values inside of an array that will end up running. The other option is if we do a particular type of tree traversal, we can skip the map altogether. If we do an in order depth first search, we will traverse all the values in order, hence the name. So we're going to do the in order depth first search approach, and this is the tree we'll use as our example. So inside of this tree we have 33 and 63. These numbers have the largest counts inside of the tree, and so we need to return both of these numbers. So like I mentioned, if we do a depth first search, we'll visit the node in sorted order. So 18, 22, 25, 33. And so if we visualize this a little bit differently, we would visit the nodes in an order that looked like this. So our algorithm will take advantage of the fact that this is visiting the nodes in a sorted order. So we'll compare the node that we're currently at with the node that we've previously visited and compare their values. We'll have a count that'll keep track of how many times this has occurred, where the previous is matched our current, and we'll add these numbers that either create a new max or match the current max to our result. Alright, so 18, does it match anything? No. Alright, so that's a count of 1, and then we'll add it inside of here. So then 18 becomes our previous value, and 22 is our current. We compare them. Alright, the count is set to 1 again. It matches our current max, so then we put 22 inside of here. And this process continues until we finally hit 33. So we would have 25 and then 33 inside of here. Alright. So our count is still 1. So then, alright, does 33 match the previous? Yes, it does. So now we have a new count of 2, and we're going to just completely wipe this array altogether and put our new value inside of here. And then, again, 33 is our previous. That matches. So then we get a new count of 3. The array gets reset again, and we only have 33. So then we won't add any more values until 63 finally reaches a count of 3. It'll match. We add that in there. Boom, those are our two numbers that we'll return. Alright, so let's go ahead and code this out. Okay, one of the first things that we want to do is let's create our array, which will store all of our numbers in. We want to make sure that we're declaring it with let so that we can reassign it all together. Our previous node, we're going to start it off with a root, and our count is going to be 0, and our max is also going to be 0. So since we're doing depth first search, we're going to do a recursive function. So I'm going to call function called traverse. This takes a node, and then we're going to call it down here with our root that we get, and then we're just going to return result. Alright, so now let's work on the inner inside of this traverse. So if we come across a node that's equal to null, we're at the end of our branch, and so we'll just return. Now we need to immediately traverse the left side, and then once we've traversed as far as we could, we'll come back out of that function call, and we're going to set count based off of some conditions. So if the previous node's value is equal to our current node's value, we're going to add count plus 1 and assign that to count. Else we're just going to assign count to the value of 1. And now our previous node becomes our current node. And now we get to ask some more questions. All right, if the count is equal to our max, what are we going to do? We're going to push the node's value into our result. Now, if the count is greater than our current max, we need to reset our array. So we're going to say result is equal to a new array of node.value, and then we set our max to count. Okay? And all that's left to do is to traverse the right side. And that's all there is to it. So this is just a simple in order depth first search traversal. And then inside of that, once we're looking at the node, we just ask some questions with that. And we will reassign the array, and we'll keep track of the count to know which elements we should or shouldn't be adding to it. All right, and at the very end, we return that array with all of our results. So let's go ahead and submit this. There we are. All right, I hope this was helpful for you. If you have any questions, any concerns, anything that you feel that could make this better, please leave a comment below to have a conversation. And other than that, I hope you all have a wonderful day.